Well, hello everyone. Today I'm going here. First, let me introduce myself. So let's get started with the CONIC sections. Today I'm gonna get a good introduction to all the CONIC sections so far as I remember, and I want to get a close look at to their properties, and we're gonna have a good fun today with this session. So let's get started. So first of all, what is a con? You might have seen your birthday caps. That is the shape of con, and the con looks very beautiful, and you always want to have it on your birthdays. Except that you can look at your ice cream cone. That's also in the shape of a con. So if you remember the shape, then it might be very easy to understand the sections of it. Now, why I'm talking about the sections of it? So let's look at it here. So if I'm taking a cone like this way, I know my drawing's so bad, so please pardon me because of it. Okay, and I've taken another coin right over there. So there are two cones just clinging to each of them at the end of their point, and then I've taken something like a sheet of paper and something which doesn't have any third dimension. It's of just two dimensions, and let's take a paper sheet and it cut it down from center, and the way it cut down this cone, the angle it obtains by the cone really matters, because it is because of all the different type of sections we're gonna talk today. Okay, so in contrast, I want to say from this that this angle is really because of all the conic sections, and the different conic sections are the result of just because of the angle that this whole two-dimensional sheet obtains by the cone. Okay, so if it obtains by 90 degrees, okay, I mean it. I don't have any pictures right here. I know it's very hard to understand, but if you listen to me very carefully, you will get the idea of like what I'm saying and what is the meaning of things, of the words I've been using here. So okay, I want to say from this that if it obtains at an angle of 90 degrees, then we got this type of shape, something like this way. Here is upper part, and all the lower part is there, something looks like this. So it cuts at like it cuts like a circle, and when it obtains over 90 degrees. Okay, so this circle has some properties. If I place it on a coordinate plane, since I know it's a two-dimensional coordinate plane because I've taken this sheet as a two-dimensional sheet, so I've taken the plane as two dimensions. So here is, I'm giving a disclaimer here, there are infinite dimensions further, where I'm saying that there are infinite number of dimensions for the objects you've seen. They're not 3 dimensions, they're only 2 dimensions, there are 4 dimensions, 5 dimensions, and infinite dimensions in the space and the universe. Okay, so here let's come to the topic back. So this is a circle which contains a number of properties, and some of them, let me just introduce with some of them to you. It is just like, there is a circle which has a center. I've named it as H, K. H and K. This is a radius, of course. This is a radius, and we know that just from this point, from radius to any other point on the circle, the distance remains always constant, always same. I've taken another point here. I've called it X and Y. Tick. Okay. So the distance from radius to this point is constant. We know this. So we're not going deep to the derivation. We're just gonna have a quick and a very precise look to all the facts, to all the equations and many other things. We're not gonna go deeper inside it because it's just out of the syllabus for a high school student. Where if you're more interested in talking about derivation, I will post it up later if you wanna know. Okay. Here is the equation of circle. It is x minus h whole square plus y minus k whole square. It is equals to r square, where h and k are the coordinates of the radius or the center of the circle, and r is the radius of the circle, and x and y are the points or any literally I'm taking just any point on the circle. I've just named it as x and y. I've told you just before there's some sentences. Okay, here we got into another section of the cone. When it is an acute angle, I mean to say when this sheet of paper cuts this whole cone and very in acute angle. Before we talk about a perpendicular angle, now I'm talking about the acute angle. When it cuts an acute angle, you find that the shape so formed is a parabola. We call it parabola. So the parabola has a shape which something looks like this way with my bad drawing this right up there. Okay, now this parabola indeed is very complicated to understand. So to get to an extreme easiest way to the high school level, we're just gonna talk about the simplest parabola, which passes through the origin of the coordinate plane. So okay, so we're just gonna in the same parabola with 4 different parabolas, and of course 4 different equations too. So this is a parabola, this point is the origin, which I've named as O. A circle has a center, often named it as, let me name it as O. So a circle has a center, whereas a parabola has a foci or focus. You know foci stands for, it's just a plural of focus. So okay, so parabola has a focus, which is I've named as coordinates as a comma 0. So if it is a distance away from the origin, then this line is known as the centrist. Okay, and the point x is equals to minus a. So why is this so? This is particularly a trick. Okay, so this directrix, let me name it here, has directrix. So this directrix has an equation which is x is equals to minus a. Is it for always? It is true. Is it true for always? You might be asking to yourself or to your teacher, or you haven't had some kind of this doubt, or you didn't go out to ask. But let me have a quick answer to that question. Is that no? This is not true for every case. There are 4 different cases. I've told you before, the parabola, the simplest parabola, has 4 different more parabolas, 4 different cases with 4 different equations. And that's true, you've known it. Okay, so this directrix has an equation which is x is equals to minus a. You need to know just one simple thing, one simple concept, which is that a parabola has a directrix behind it, and that behind directrix may be negative or may not be negative. And how can you recognize that? Let me tell you. Okay, so it can be easily recognized when you see this coordinate. When this A is positive, this A is always negative because it is behind this A. So if it's positive, it must have to be negative. Okay, so this parabola has equation y squared is equal to 4ac, and I'm not going that deeper to get the derivation of all these. Okay, I hope you understand. Okay, let's get to the next point. Going to the next point, this is second case of parabola, where the parabola so formed is on the left side of the coordinate plane. So the directrix is on the right side. Since the right side of the x-axis remains positive, so this A is positive. If this A is positive, that means this A should have to be negative. And the equation so formed has to be y squared is equal to minus 4ax. This is x. So don't be confused. This is not c. This is x. Sorry for my handwriting again. Now, in the third case, the parabola so formed is above the x-axis, which is along the y-axis. Now, this was along the y-axis and on the x-axis, and this one's above the x-axis. And this one was vertical frame. Now, this one is a horizontal parabola. Is when this horizontal parabola focus formed is 0, a. It's not a, 0, it's 0, a. A, 0 is used for this type of vertical parabolas. In the vertical parabolas, y-axis is always 0. Coordinate with y-axis is always 0. But in such cases, the coordinate for x-axis is 0, not for y. Okay, so f is equals to 0, a, and the directrix, which is behind the parabola, is y is equals to minus a. Okay, so the equation so formed is x squared is equal to 4ay. Okay, let's get to the last but not the least case of the parabola, where the parabola formed is it's just downwards. It's a downward curve, and the directrix is behind it, which is y is equals to a. If y is equals to a, then this a must has to be negative, and the equation formed as x squared is equal to minus 4ay. Okay, let's get to the latest rectum. Now, what this thing is, this is my native language, so just ignore it. So, latest rectum is 2 points on the parabola which connect to them. So, I'm taking this point and that point. I'm joining them. But this is the latest rectum. Okay, I hope you understand. So latest rectum. So now ellipse. This is another curve which is so formed because of the conic section, because of angles obtained by the plane to the conic section. Okay, so ellipse. You might have heard of this shape before. Yes. Where you've heard about the Earth rolls an elliptical path around the sun. So this is the same path Earth used to roll around the sun. And this was the same path, parabola. It's the same path we used for the projectile motion. You might have started motion in 2D or motion in 2 dimensions, and thus you've studied about the motions of forms in the shape which is known as parabola. So that motion is called projectile motion. And the ellipse motion is elliptical path. This is a path of Earth which Earth uses to revolve around the sun. So it has two foci, two focus, and the plural focus of called is foci. So it has two foci, and this axis, which is greatest in length, is called major axis, and the smaller axis is called minor axis. Now, this triangular distance is always constant. So PF1 plus PF2 is equals to constant. So length of the major axis is equals to 2a. How is it 2a? From this point to this point, the distance is a. And therefore, the distance is a because the line is in the center of the ellipse. So a plus a, 2a. This one's b. This one's also b. So b plus b is equals to b. 2b, sorry. 2b. So semi-major axis length is a. Semi-minor axis length is b. What is the semi-major and semi-minor axis? This half axis is called semi-major axis, and this half axis is called semi-minor axis. Okay. Let's move ahead. Now, let's get to another point, that's distance between foci is equals to 2c. Okay, so relationship between major axis, minor axis, and foci, it is a square is equals to b square plus c square. Special cases there are two special cases out there, so I know. First one is if c is equals to 0. If c is equals to 0, that means a square is equals to b square. If a square is equals to b square, square cancel out, which means a is equals to b. This means f1 gets merged out to f2 because f1 is equals to f2, which means merging out. That results in single foci, and which is always in a circle. So the shape gets changed into a circle. It gets reduced to a circle. Okay, now this is c is equals to a in this line segment. If this case is affirmed, then what do happen? Then c is equals to a. So this c becomes a square, so b square plus a square. This a square gets a square cancel out. We got just b square is equals to 0, b is equals to 0. So if c and the 2 points are becoming same, then it gets reduced to a line segment. Now, eccentricity. Now, what is eccentricity? It is, So eccentricity is the ratio of the distance between two foci of the curve. Now, this curve can be ellipse or hyperbola, which we're gonna talk a bit further today. So it can be any curve which having two foci, and the distance between two foci, ratio of the distance between two foci, actually, it is called eccentricity, which is equals to, it is eccentricity is always smaller than 1 in the case of ellipse. Okay, now let's talk about it in detail. So this point is c comma 0, this point is 0 comma b, and this point is this. I've mentioned all these here. And the equation of the ellipse is x squared. This is not minus, this is just x squared. So x squared upon a squared plus y squared upon b squared is equals to 1. X squared upon a squared plus y squared divided by b squared is equals to 1. But this is the equation for the ellipse, which is formed along the x-axis in a horizontal manner. If it's formed in a vertical manner, like this, along the y-axis. The equation is x squared upon b squared plus y squared upon a squared is equals to 1. Let me repeat it up. X squared upon b squared plus y squared upon a squared is equals to 1. So latest rectum is 2b squared upon a. Let's talk about hyperbola, which is today's last topic. Hyperbola. So this is the hyperbola. This might be looking like two different parabolas opposite to each other, but they are actually very connecting and related to each other. But this is just about, you just need to know that PF1 minus PF2 is constant. This is different. These two parabolas, these are looking like parabolas, but this is hyperbola because this has an opposite meaning to the parabola. So like PF1 plus PF2 is equals to constant in the case of parabola, but when it comes to hyperbola, it is PF1 minus PF2 is equals to constant. And if it's vertical like this way, then the equation is x squared upon a squared minus y squared upon b squared is equals to 1. But when it is horizontal, something like this way, then the equation is y squared upon a squared minus x squared upon b squared is equals to 1. Let me repeat it up. Y squared upon a squared minus x squared upon b squared is equals to 1. And the eccentricity can never be less than 1. And the latest rectum is 2b squared upon a, just like in the case of ellipse. This axis is called transverse axis, and this one is called conjugate axis. Just like major axis and minor axis, there are transverse axis and conjugate axis. And the relation between transverse axis and conjugate axis, transverse axis is basically equals to 2a and conjugate axis basically equals to 2b. And it is the relation between both of them is equals to a squared plus b squared, which is equals to c squared. A squared plus b squared is equals to c squared. Okay, I hope you got much information from today's session if you loved it. So see you in the next lecture. Till then, take care of yourself.